We have the inventor, the creator, the maintainer. He is now the CEO, the chief email outputter, one and only.
Being in an environment where people were trying to run these critical production services and just being a part of that process.
But a lot of people always also ask me, how to become a DevOps engineer.
And was the first time I had really been on call for anything. What it was like to be responsible for a system, what it was like to wake up at 3 in the morning, having a sense of empathy for what it's like to be in that role. Everything we do in Linkerd is very human focused.
But then for folks coming into DevOps, it can be quite tricky because they don't see the whole picture.
Yeah. Oh, sorry. I'm just adding more to the plate. Every language has its strengths and weaknesses. And that actually ends up being hugely important for all of this stuff.
What was your first experiences with containers?
Holy crap, what is what is all this stuff? Honestly, it took me a while to really come to terms with why this was useful. The thing that made it interesting for us was suddenly everyone seemed to be adopting it. We knew that managing the communication between services was really, really important. And people would say, well, I've already got all these other proxies. And we'd say, no, it's different. We'd say,
what is up, folks, and welcome to another video. And we're going to be talking about service mesh today and Linkerd, and I've got a bit of a surprise for you guys today as well. So for those of you who don't know what a service mesh is, service mesh facilitates service-to-service communication. So when you're building microservices and you have a service talking to another service, there's a lot of things that can go wrong. At the network level, services can fail, they have to retry. We may want to know requests per second, latency. We may want to route X% of traffic between different services. There are all these things, and service mesh takes the complexity out of the code base and allows the services we basically make the network smarter instead. So that's pretty much what a service mesh is at a high level. If you want to know more about service mesh, I've got a link below to my introduction to service mesh, so you can see if that's something that you're interested in. And if service mesh is for you, I've got another video down below, which is an introduction to Linkerd. So what is Linkerd? Linkerd is a service mesh, lightweight, super fast. It's one of the first. And I don't want to waste another second talking about service mesh because today we have the one and only. We have the inventor, the creator, the maintainer. He is now the CEO. Which he calls himself the chief email outputter at Buoyant. I have William Morgan in the house today. So William, over to you. How are you doing?
hi, Marcel. Very good, thanks. How are you?
I'm good, thanks. Yeah, thanks so much for coming on. It's very exciting.
I was so blown away by your introduction to service mesh and the Linkerd one too. I had to be here.
Thank you. It's an honor. I've been watching a lot of your stuff on, the CNCF videos. You've done a lot of talks and things like that. So, yeah, how are you guys doing with these crazy times? Are you also working remotely?
Yeah. Yep. So everyone's working remotely. It actually has not made a huge difference for Linkerd because so many of our contributors have been interacting remotely and, live in different places in the world, and everything is just happening on GitHub. So it has, in a weird way, it's actually been a little beneficial for Linkerd because it's actually driven some adoption. We had a KubeCon talk a couple weeks ago from a big grocery store chain here in Texas called HEB about how they used Linkerd to roll out their curbside delivery program so people could get their groceries without having to go into the store. So yeah, it's interesting.
That's amazing. It's awesome to see how people are adopting service mesh. But before we go into Linkerd, before we dive into service mesh, I think a lot of people on this channel are coming from either they're coming from a DevOps background or they're coming from a programming background. Some of them are students. They might be looking at how do I get into DevOps? So maybe before we dive in, let's go back before Kubernetes was a thing, before Linkerd, before service mesh and containers. Life was simple, I guess. I think we did development and we did ops. So who was William back then? And give us a bit of backstory. What were you doing back then?
The origin story. Okay, well, it's not actually that exciting, but I'll give you my story, which is I actually came into this in a very circuitous route. I was really into things like natural language processing and machine learning, and I was also really into Twitter. And so around 2010, I actually got a job at Twitter as a software developer, but on the natural language processing, machine learning side of the house. And so we were doing some interesting things. This was, now 10 years ago. But a weird thing happened, which is uh, I found myself really spending a lot of time with everyone on the infrastructure side of the house. And as time progressed there, I ended up doing way more infrastructure and DevOpsy things and being much more excited by what was happening there than anything on the natural language processing or machine learning side of the house. So I kind of got into that world through that route, but I was still very much coming at it from the perspective of a developer. And it was really only a little bit later in life when I started making the kind of shift to the DevOps and kind of more holistic view of the world.
Yeah, that's awesome because I meant to make a video about it, but a lot of people always also ask me, how to become a DevOps engineer. And I've also come from a programming background. So for me, it's like because I've had a little bit dibbling and dabbling into servers, like we compile the code and then we go to remote desktop or SSH and we paste the binaries and then, hold thumbs, everything goes good. And that's what DevOps was back in the day.
Right. Yeah, exactly. Yeah.
Yeah, so I mean, for DevOps engineers that want to start out, what sort of advice could you give, given like your journey? What do you feel like is the best place to sort of start?
Yeah, so the thing that was really transformative for me was being in an environment where people were trying to run these critical production services and just being a part of that process. People would deploy, and again, this was at Twitter, which was a very transformative experience for me, and was the first time I had really been on call for anything, or I had been really directly responsible for any kind of production infrastructure. So just being a part of that process, seeing what happened, not just at the computer side, but also at the human side, what it was like to be responsible for a system, what it was like to wake up at 3 in the morning and have to, fix something because if you didn't, the service was having a real problem. And I think, maybe this is kind of a strange answer, but I think a lot of what has been beneficial to me has been having a sense of empathy for what it's like to be in that role. Everything we do in Linkerd is very human focused, and that's not always the case in infrastructure projects,
Yeah.
right? You tend to get into these projects as you want to build these cool platforms, and like it's awesome to get the computers to do all these things in a coordinated fashion. You got distributed systems, that kind of thing is fun, but you have to remember at the end of the day there are humans who are responsible here, and they're humans who are gonna have to wake up at 3 in the morning, or gonna have to spend all Christmas Day, which something I had to do once, and I never want to do that again, fixing computer problems when things go wrong.
Yeah, that's awesome to hear because a lot of people, coming from development side, they're so either focused only on writing code, and then on the ops side, they're only focused on keeping the server up and running. But then for folks coming into DevOps, it can be quite tricky because they don't see the whole picture. So DevOps is one of those roles where you can't just go online and like get a certification. I mean, you got to know Terraform, Puppet, Chef. You got to know Golang, Rust, 9 different programming languages, and then you got to know containers and Kubernetes, and now we have service mesh as well in the picture.
Yeah. Oh, sorry. I'm just adding more to the plate.
To you, I think there's like a lot of sides to it. Like one side is yes, you may not need to know any kind of coding or to be good at DevOps, but then there's the other extreme that says you should know 9 languages before you start going into DevOps. So what is your take, being that you came from a programming background?
I don't think you need to know 9 languages. You need to know, you know, well, I don't even want to put a number on it. You need to know enough that you have a sense of the strengths and weaknesses of each thing, right? There are things you would do in Bash that you would never do in Scala, and there's things you would do, every language has its strengths and weaknesses. But really, in my mind, I think it's the thing that seemed to work really well for me, at least, and I can only really speak for myself, was the apprenticeship model. It was really being in that environment and seeing how people had to respond that allowed me to develop kind of the intuitions about how to even reason about this, right? How much risk, one of the hardest things I think to know in this world is how much risk is associated with a change, right? When I'm doing something on this Kubernetes cluster or with this application, is that a risky thing? Should I be careful? Should I have someone watch over my shoulder? Should I write everything down? Or is it just like a really easy thing and I'll just kind of do it? Those sorts of intuitions, I think, can really only be developed with practice and by being in that environment and by having senior people around you that you can look up to. So I'm a big believer, I think, in the apprenticeship model for this sort of thing. I don't think it's something that can be directly learned from a book. I don't think it's something that can be directly learned from a course, although certainly that foundational material is always helpful. I think you have to be there to really to really be able to develop those intuitions.
Yeah, you've got to put yourself a little bit like in the shoes and actually,
Right.
write a bit of Python to see, okay, Python is really good at chopping up data, and then
Right.
maybe write a Golang binary, and then you see how portable it is, or the performance of Rust, and they all have their ups and downs.
Right.
Yeah. So
Yes, exactly.
So let's talk a bit about like operating systems. Like when there's all these debates. What's the best operating system? Windows, Linux. I get a lot of flack on my channel. They see I use Windows, and then I
Uh-huh.
say I'm in a container. It doesn't matter. I'm always exec into a container, so I'm always writing in Bash. So what's your operating system that you use?
You know, I cut my teeth on Linux, so I grew up in that world. I'm old enough now that I remember the lunchroom of my high school, people were passing around Linux distributions. I think it was Slackware and like a stack of floppies, and this was like the cool thing. And everyone would install it, and then I'd bring it back the next day, and the next person would install it, and like it didn't hardly work at all. You could like maybe get your computer to boot it, and like you certainly couldn't get like the drives to work or the monitor to display graphics or anything. That's where I cut my teeth. But the reality is at this point, my operating system is like the web browsers. Like I spend all day on email.
Yeah.
I don't even know what's running under the hood. I'm just like typing emails to people. So I don't know if that's good or bad. I've like evolved into this beautiful state where all I do is write email.
Yeah, that's pretty good. I noticed like myself when I started moving to Linux as well, is I just when you're in an environment where you need to have Outlook and you need to have Microsoft Word and all these things, it's like you just open the browser these days. It all runs in the browser, and you can run Chrome in Docker, which is also
Right.
pretty
Yeah.
pretty cool.
Yeah, and I think if you look at if you look at what happens at Buoyant, which does a lot of the Linkerd development, we actually see a range. We see folks developing on their MacBooks. We see folks with Linux boxes. We do have folks developing on Windows, and then we have people who use their very expensive fancy laptops as dumb terminals to SSH into a remote dev server, and that's where they're doing all their development. So we really span the range.
Yeah, I find that really it's useful for people to hear, because a lot of the time, I get a lot of questions, why are you using Windows? And I mean, I use Windows for software for video editing, but then I also know that my audience are mostly Windows, or my
Mhm.
audience also
Yeah.
they're developers who use like Visual Studio or VS Code running in Windows. So if I start using like a crazy, ZSH terminal with all these fancy stuff, I think you sometimes lose people, you lose an
Yeah.
audience because they're not familiar. I like to put myself in their shoes. And I mean the same thing. I mean, if you're building and compiling Linkerd, and it's running in a container, it doesn't matter whether the developer is building it on a Windows system, because at the end of the day, those binaries are compiled probably in a container, and they're running a container. So
Yeah,
you
yeah,
know,
that's right. That's right. And that actually ends up being hugely important for all of this stuff. And in fact, I would almost say that the reason the service mesh exists is because of containerization, because it made it possible for us to run things in these containerized environments and not actually care about what was happening inside the container. Right? Like we
so
build it in one language or in a different one, like it doesn't really matter. It's just containers that are running.
yeah, it's just the process at the end of the day.
Yeah.
So when Docker came out, or when containers became a thing, so now we're moving a little bit more closer to service mesh. So Docker became a thing, and everyone's talking about containers. This is now before Kubernetes. What was your like first experiences with containers?
Well, it's funny. I was stuck in this, weird Twitter like black hole almost, where I wasn't really aware of all these things happening, in the outside world. We were running things in on the JVM, and we were running things with C groups. So you could kind of argue, hey, that's kind of like a limited form of a container. We had like encapsulation of the JVM and resource limitation via C groups. But when I left in 2015, I looked around and I was like, holy crap, what is what is all this stuff? I've never heard of these things. And it honestly, it took me a while to really come to terms with why this was useful. I had a hard time really understanding it because I had come from such a different background where things had evolved in a world where we didn't need that. We just used the JVM for everything. So it took me a while to come to terms with it. Once I did, then, I guess I built my entire career around that. So it was a good realization to have.
And I mean, at that time, I think Kubernetes also just came out just after. So given like you came out of the JVM world
Yeah.
and you're jumping into containers, and then Kubernetes came out also
Yeah.
at the same time. What was your introduction to Kubernetes like when you started out?
Yeah, so at that point, I had had some experience with Mesos, so I at least understood the idea of container orchestration. Sorry, of orchestrated environments, not necessarily container orchestration. And when I started at early on at Twitter, you would launch a new service and you'd go to the guy who maintained the spreadsheet of machines and you'd ask him for machines, and you would say he didn't have any, and then you'd like bring him a bottle of scotch and he'd say, okay, well, here's the three machines that you can use. And by the time I left, we had progressed to this very advanced, sophisticated Mesos-based system where you just say, okay, run 20 copies of this, and I don't care what machines are on, you figure it out. So I was at least familiar with the kind of the basics. And then when we encountered Kubernetes, so it kind of made sense. And then packaging it with what I knew about Docker, it kind of made sense. But I don't think we really had any particular affinity or dislike. It seemed like a cool piece of technology. The thing that made it interesting for us was suddenly everyone seemed to be adopting it. And we were like, okay, well, this is where the world seems to be moving, at least this tiny little, cloud native like ecosystem. So that's something that we need to start investing in and getting really, really good support for. And, now, of course, fast forward 5 years later, and like everything in my life is running on Kubernetes. And, now I like mumble that word in my sleep, probably.
So was Linkerd on your mind when you came into the Kubernetes space? Was that something that you thought about early on?
Yeah, it was. Actually, the very first version of Linkerd was this kind of multi-platform thing that could talk to Mesos, it could talk to Kubernetes, it could talk to Nomad, it could talk to Zookeeper. We treated these all as like these service discovery endpoints. And what happened over time is we actually lost that ability, and we just started focusing very, very heavily on Kubernetes. Again, not because we have some fundamental belief that Kubernetes is the right thing to do, although there's a lot about it that I like, but more because that seemed to be where people were really having the sorts of problems that Linkerd could help with.
Cool. So the whole idea of service to service, I mean, obviously you probably knew that there was like a gap, between service to service
Yeah.
communication. There was something there that was missing.
Yeah.
So did you have that like ideology or that idea to fix something in that space before Kubernetes was around? Were you thinking of that in the
Yeah.
JVM world as well?
Yeah, that's right. So a lot of what happened at Twitter was we ran these, we basically moved to this big microservices architecture, although we actually didn't have the word microservices at the time. So as part of that, we introduced this crazy new thing into our production stack, which was the service to service communication. We never had that before, right? We had a monolith. It was like function calls. Function calls are very easy to understand. And now all of a sudden we've replaced some of those function calls with network calls, which are slow and which fail. And we were like, oh my gosh, like, is this the right idea? So we actually had to build a bunch of technology just to handle that new type of communication. So by the time, we were thinking about Linkerd, and I should say that, I talk a lot about Linkerd, but the reality is not writing the code. I'm writing the emails. There's a huge community of very, very sophisticated and great engineers who are the ones actually building Linkerd. So, I'll just put that caveat in there. I'm not actually doing the work. I'm just like benefiting from it. But by the time we were even thinking about Linkerd, we had that in the back of our mind. We knew that managing the communication between services was really, really important, and then we also knew it was actually a really nice place to start introducing features because you could do it in a way that was not tied to the application code, right? Just like you said in the beginning of the episode, getting this code, whether it's for retries or circuit breaking or TLS or whatever, getting that out of the application was really, really powerful. So those two ideas together kind of, had this happy marriage. And that then met containers and Kubernetes, and all of a sudden it started becoming really useful to a lot of people.
Yeah, and I think that's something a lot of people don't get. I mean, even in the traditional world of infrastructure, they probably already have like a manual service mesh, because if you look at it, like in front of your monolithic application, you have probably an Nginx or an HA proxy, and then behind it you probably have a Squid proxy because you're keen to know what's going out, and so people are adding these proxies, back in the day as well. So I mean, this just makes it a lot easier.
Yeah, that's right. And actually, we had a lot of difficulty early on describing what Linkerd was because we would say things like, before we had the term service mesh, which I have kind of mixed feelings about, but before we had that, we were calling it we were calling this thing an RPC proxy. And people would say, well, I've already got all these other proxies. And we'd say, no, it's different. And they'd say, well, we're not doing RPC, we're doing HTTP. And we'd say, well, actually, part of RPC is like HTTP, it's like a subclass. And, by the time you had that conversation, they'd kind of wandered off and they didn't know what you were talking about. So, we had a lot of difficulty describing what it was until we invented this term, which kind of didn't have a lot of meaning at the time, to describe the pattern of deploying these proxies in this particular way with this particular feature set.
Yeah, people had to probably get their feet more wet in the Kubernetes space to actually understand, well, now I've got all these services that are talking to each other.
Right.
Because if you talk about the word proxy, then Nginx and HA proxy and all these other proxies come to mind. And I think it's
Right.
quite hard to compete with some of those older proxies, that are battle hardened. So if people are not aware of what a service mesh actually tries to solve, I could see that become quite a challenge.
Right. Yeah. And it wasn't even about competing. It was this new use case, but it was just, you're used to proxies being used for edge traffic, or used to them, for these very specific use cases. And we were asking people to do something very different from what they had done before. So maybe it's a marketing lesson. Put a new name on it, and suddenly you can have a better conversation about it.
Yeah, I found this kind of blew my mind. Last night I went into GitHub and I went into the Linkerd releases, and I went back. I think it goes back all the way to 2016, and
Oh my
I
gosh.
I remember like back then. I think some of the cloud providers did not even have Kubernetes out. I think Google was probably the only one, and like a lot of people did not even know. You fast forward to now, people are starting to trying to learn Kubernetes, and there you were already back in 2016 solving a problem that we're trying we're only trying to comprehend like in 2020. So
Right.
I found that quite interesting, like how Linkerd was what it was that far back.
Well, it sounds like we're geniuses when you say it that way, but the reality is we kind of stumbled into this. We took some stuff that we knew was useful from our experience at Twitter, we packaged it up in a certain way, and it was really the advent of and the rise of containers and container orchestrators that made this suddenly a useful thing. At any point in time, we could have said, "Hey, here's 10,000 proxies, deploy them everywhere," right? And people would have looked at you and said, "No, I'm not going to do that." But now that you have some of the tooling that makes that a feasible, deploy time thing to do, it suddenly makes sense.
Cool. So what were the challenges in, I mean, when you move now to 2016, 2017, as Kubernetes is now evolving, what were some of the challenges you faced as like just building Linkerd in those early phases?
Yeah, a lot of it was, I think, at least at that point, it was describing what this thing was, and why it was important. And again, I think this comes back to the human aspect. You're asking people, people have a lot on their minds, right? Like
Yeah.
I'm already struggling to like keep this all together. And now you're asking me, I've got 50 things in my mind. You're asking me to think about thing number 51. It's called a service mesh. It's got 10,000 proxies. I don't, that just sounds like a complicated, annoying thing to deal with. I'd rather not think about it. So a lot of it was those kind of evangelization conversations where you'd say, hey, look, I actually think it sounds weird, but I actually think it's going to help you, and it's going to help you in this way. Um, that was a primary challenge. At some point, that flipped over, and everyone recognized that, okay, service mesh is a thing. Maybe I don't need it, but it's at least a category of thing that I should be aware of. And then we moved on to a slightly different type of conversation. Oh, which service mesh is best? What is a service mesh anyways? But getting to the point where it was a noun, or it was like in people's vocabulary, that took a lot of effort.
And what were your like technical challenges? So when you had to write the code and all of that, what are some of
Yeah.
the things you had to overcome there?
Yeah, so that was really interesting. So for us, we started on the JVM, like I said, and we actually started with this open source library that we had built out at Twitter called Finagle, and we took Finagle and we kind of wrapped it up in a proxy, and it did all the features that you wanted. Finagle was pretty well developed at that point. So, and Finagle, for those of you who are familiar with like the Netflix stack, there's this Netflix library called Hystrix. It's kind of like that, but so we had those early versions of Linkerd that you were looking at way back in 2016. They were basically Finagle wrapped up in proxy form. And that was great. We had all the features that we wanted, but there was a problem, which is that the JVM is very good at scaling up, but it's not very good at scaling down. And what we were asking the JVM to do, was not to run one mega proxy to handle, tens of thousands of requests per second. We were asking it to be as small as possible, as light as possible. And as much as we tried, we couldn't really get the footprint of this early version of Linkerd down under 120, sometimes 150 megs. There's too much in there. There was the JVM itself, there was Scala, there was Netty, there was Finagle, all these things. And so that was a difficult technical challenge for us, because what we were asking people to do was to deploy these proxies alongside their applications. And if their application was, a 3 gig Java app, then like that was fine. But if it was this little 50 meg Go microservice, there's no way you would add a proxy next to it that was 3 times its size and think that that was a reasonable trade-off. So at some point, we had to bite the bullet. And we had to say, what, we have to get off the JVM. As much as we love Scala, much as we love Netty and Finagle, we need to rewrite this thing. And so that was that was a scary moment. Honestly, that was a scary moment because we had to kind of start from scratch.
Oh wow! So was it written in Java back then?
It was written in, even worse, it was written in Scala.
Oh wow! Okay, so that was the first Linkerd concept prototype at the time.
Yeah, yeah, and people were using it in production. It was more than a prototype. It was powering these things, but pretty major parts of the infrastructure. I think if you go to, well, yeah, I won't name any names, but yeah, big things were powered by it and continue to be powered by it. But there were just so many use cases we couldn't address because of how large it was at runtime.
And then I think I read somewhere it's written in Rust. Was that like a recent shift, or did it go through a couple of evolutions?
So that was the big rewrite back in 2018. I think we started kicking this off, and we said, okay, let's take a step back. We know what the value of the service mesh is. If we had to rewrite this thing from scratch, and by the way, this is a terrible idea, right? Like you can look this up on the internet. It's like second systems syndrome. It's like anytime you try and rewrite something from scratch, that's already working, you're going to end up with like a disaster. It's never going to work. So, we were idiots and we just did it anyways. And I think happily it seems to have worked, but it was pretty risky. So we said, okay, what's the ideal set of languages, and actually we ended up with two. So we ended up with, there's this idea of a control plane and there's this idea of a data plane. And on the control plane side, we chose Go, because Go it's the lingua franca of Kubernetes. It allowed us to use all these Kubernetes libraries and things. It made it very easy for open source contributors to join the project. But then on the data plane side, so this is the actual proxies themselves, we ended up using Rust. And Rust is a hard language. It's not an easy one to pick up, certainly not compared to Go. But it had three things that we really liked. I think it was three. Number one, it allowed us to write proxies to compile to native code, which means that it's like writing something in C or C++. You can be as fast as the computer will let you go, basically. It's not like the JVM where there's a managed environment, or even Go, which has a runtime. We could be significantly faster than any of those things. So that's really important. Number two, it allowed us to control our memory management, and that was also really, really important because what happened on the JVM, and what happened even in languages like Go, is you have a garbage collector in there. And that makes the programming very easy, but it means that every once in a while, that garbage collector decides, oh, it's time to collect the garbage, and it does that in the middle of processing a request. And that means that your latency profile ends up being spread out. So you have this long tail, and that ends up being very annoying for network proxies because you introduce latency in kind of inopportune times. And then number three, the third thing that we really liked was Rust gives us this security kind of blanket. Because Rust is designed to manage all the memory and to understand the kind of ownership of that memory, you get not only these native code performance, but you actually get the ability to just sidestep entirely this whole class of scary things that happens in C++ code, which is buffer overflow exploits and like these memory vulnerabilities, right? So Rust allowed us to enforce that in compile time. So that was great because what people do with Linkerd is they pass really sensitive data through the proxies. They're using it for health data or personally identifying information, or they're using it for financial transactions. We can't mess around on the data plane layer. We've got to be really, really fast, and we've got to be really, really secure. So yeah, long story, but we started with the JVM and we ended up with splitting it into half Go and half Rust.
That's really awesome to hear, because that kind of goes back to our earlier conversation of choosing programming languages, and DevOps folks need to kind of understand that there are pros and cons between all of them. And some people are like pro Java, then there's Python folks, and I write everything in this scripting language or that scripting language. But when you break it down like that, you can see you're using the performance of Rust and some of the improvements that it has over C and C++ and those languages. And then you've got Go that helps, and this is something really cool that I've also noticed in this conversation, is that Go provides all these libraries. So when you want to code against Go, you don't have to find libraries that may not support some of the things. So writing the control plane in Go and then the data plane in Rust is really, really informative.
Yeah, and I like that way of putting it. I think every language has its advantages and disadvantages, and once you have kind of hit your head against a wall too many times, you eventually come to the realization that it's not about this language versus that one. It's about which one is the right tool for the job, right? And for us, the requirements for the control plane were very different from the requirements from the data plane, so we ended up with two different languages.
Cool. Yeah, for those of you who don't know, the control plane basically runs kind of like the Kubernetes control plane, where it kind of governs everything, and then the data plane is where the proxies run. So they run side by side with your applications. So when I look now, there's all these things like Open Service Mesh, and there's a whole lot of Service Mesh proxies out there, and they seem to also have a data plane and a control plane. So you guys have kind of set the standard there, right? So you've defined these two components, and I think everyone has followed suit.
There is, there are a lot of different service mesh projects, and the majority of them follow that same pattern. There are variants that we see, but the majority of them follow the same pattern. You have a control plane that kind of sits off to the side and is, controlling everything, and is kind of the layer that you as a human interact with. And then the data plane, typically is a lot of these little, what we call sidecar proxies next to the applications. But there are variants. There are some service meshes that do it on a per host basis rather than per service. And, you see a couple variants.
So the other thing I've had people ask is around like security. So I know Linkerd automatically adds like TLS certificates between services, so it gives you that kind of SSL connectivity. And then I've also heard folks saying, well, the cloud is already secure, so why would I need a service mesh? I'm running in like a cloud provider and everything's already secure in a private network. How does a service mesh help me in that case?
Let me put it this way. Security is a complex topic, and a lot of, just like choosing the right programming language, choosing the right approach to security really depends on your requirements. I can say that for the large number of people who adopt Linkerd for security reasons, the primary driver for them is that they operate in these regulated environments like finance or healthcare that basically have legal regulations saying, hey, you have to encrypt everything when it's in transit. Or they have, for non-regulatory reasons, for their own reasons, they want to ensure that the data that's crossing the wire, whether it's on-prems or whether it's hosted, in the cloud, is encrypted. So if that's the driver for you, then Linkerd is an extremely easy way of achieving that. We'll take care of the certificate distribution and certificate rotation. We'll tie the identities to Kubernetes service accounts. We'll do all the work for you. If that's not an important thing for you, then don't use it, right? Like I don't think it's a binary decision. Like the cloud is secure, the cloud is not secure. I think it really depends on your particular requirements around that. And I'll also say, just as a caveat, that Linkerd is not a complete security solution by any means. We can do one very specific thing, which is that we can automatically encrypt, and not just encrypt, but ensure the identity. So we can authenticate the identity on either side of those connections. And we can do that, in this very low cost way to you. But there's a lot more to running a secure application than just doing that, right? There's a lot of other pieces of the puzzle that Linkerd cannot help with.
Of course, yes. And I think one of the cool things about Linkerd is that sort of opt-in. So I can add some of these features, opting in and out, rather than like deploying the mesh to my entire cluster. And I felt like that was quite useful as well.
Yeah, you can be incremental about it. That was a big deal for us because we know that it's a scary thing to adopt. So you have to be able to ease into it, dip your toe into the water first before you jump into the deep end.
Yeah, so what are the, like, as Linkerd started maturing through the years now, what is the sort of latest challenges that you're finding?
Yeah, I think the latest one, honestly, it's less of a technical one and it's more of a, kind of marketing one, which is that there's so many service meshes out there, and they all sound very, very similar. Why do I want to do one over the other? So that's definitely one set of challenges. I think more, on kind of the product and technical side, the broader challenge for us is probably around how do we make this really boring, right? So like right now, Service Mesh is hot and it's exciting and there's all these cool features and you get to talk about WASM and mutual TLS and, hybrid cloud and whatever. But we want to get to the point where, it's just this thing that you have added and it's actually kind of boring and what you are getting out of it is actually the things you're building on top of it. So a lot of the focus for Linkerd is not just how do we make it simple to operate, but how do we allow you to just pick pieces of it and just use those things? How do we make it so that it's composable with other projects? There's an initiative called SMI, Service Mesh Interface, which is a nice way of doing this. There's tools like Flagger. It's an open source project for doing continuous delivery that builds on top of Linkerd, and you can use the metrics, combine the metrics and the traffic splitting to do these really cool rollouts. That's the kind of stuff that I'm really excited about because it means that Linkerd becomes boring and you just add it and you're not spending, too much of your precious brain juice on that. And instead you're focusing on building those kind of higher order primitives around whether it's either business logic or whether it's like the operational kind of idioms that you want to use in your environment, like progressive delivery and other things like that.
So that's one of the things I noticed when I took taken a look at service mesh and I started diving into various service meshes. I noticed like in Kubernetes we write YAML, so that's like our we punch out YAML every day. When I adopted and looked at Linkerd, I noticed that there was very little extra things I had to learn in terms of YAML. What I find is a lot of these platforms that run on top of Kubernetes, they give you like an exhausting amount of YAML that you have to now learn. All these custom resource definitions with different versions, and you've got to learn about 20, 30 different variants of these things just to get it working. And
Yeah.
what a lot of people don't understand when they adopt Kubernetes is those things are just APIs and they're versioned. So when you build up a Helm chart, you're going to have to maintain that Helm chart. When Kubernetes next version rolls out, you're going to have to make sure that I need to upgrade all this YAML to the new APIs. Are they compatible with Kubernetes now? And those types of scenarios come up. And that's one thing I found with Linkerd is it didn't have a lot of that complexity to learn. I think one of the only things I really used was a virtual service or one of the service components where I could
Service profile.
service profile, and I could do. I mean, if you watch the video, I did like so much just using a service profile.
Yeah.
And I think I get my observability, I get my latency, my metrics, I get auto retry if I need it. And that's one of the things I kind of liked about it is that the adoption is very simple.
Yeah, I'm glad you noticed that because in my mind that is a profound difference between Linkerd and most other service mesh projects. And I think it comes down to empathy for the end user, right? I think having been in that situation where we are the ones operating, and actually we do run Linkerd ourselves at Buoyant as part of our SaaS service. So, we get to eat our own dog food, and sometimes it doesn't taste very good at all. But it really is different because we have focused so much on reducing what I think is the biggest actual cost to software, especially infrastructure software, which is the human maintenance cost. Once you're running this thing, right, someone's got to understand it. And someone's got to have a model in their head of like how this thing works. And when it doesn't work the way they expect it to, then they need to like figure out what's going on. That just gets really, really complicated when the surface area for you is really complicated. And there's a security angle too, simplicity is good for security, complexity is bad, but really it's more the operational cost. You've just adopted Kubernetes. It's huge. You've got this massive API to like wrap your head around and it's changing all the time. If you adopt a service mesh, it shouldn't be like doubling that complexity, right? There's no reason for that to happen. It can actually be really, really simple. Well, maybe really simple is an overstatement. It can actually be, I'll just say simple. And I think everything we've done with Linkerd, I hope can demonstrate that fact. It doesn't have to be that complicated.
Yeah, I think that was the key takeaway for me was I could do quite a lot with it with very little effort. And the other thing is also I don't necessarily want people to bite off more than they can chew. Like they start up and they think, I want canary deployment, I want tracing, distributed tracing, I want all this stuff. And then, rather than just taking a baby step approach, I think that helps quite a lot as well.
We've seen so many service mesh adopters where what happens is you bring it into your company, you install it, you get things running, and then something breaks and you get blamed immediately, right? Like,
Yep.
Hey, who added the service mesh? That's the thing that broke. And then, turns out 99% of the time it's not the service mesh at all. But we're just so familiar with that pattern that we want to give you the ability to be incremental and to like understand what's going on and, so that you can defend yourself against this thing that we know is probably going to happen.
Yeah, because you got ingress objects fighting over service objects, and then you might introduce a service profile, but the more of these YAMLs objects that you have, sometimes it just takes one person to deploy the wrong object, and all of a sudden traffic is routed somewhere else, and you start getting 504s, and they start blaming, they start blaming the mesh.
Some of these service meshes have like 40 or 50 CRDs. I'm like, I don't understand how that is feasible. So our joke is Linkerd gets to add one service mesh, gets to add one CRD a year. So every year we get to introduce one additional service mesh. And we've been under that so far. I think we only have two so far, if you include the multi-cluster one.
Cool. So a lot of people talk about, like, especially in the traditional infrastructure, they talk about concerns of, adding a proxy to your network because there's latency overhead and there's an extra hop. And now you have a proxy on the outbound, which is another hop, and then you add more services, which kind of you're adding more proxies and things like that. So I know there's a lot of content on YouTube talking about, service meshes are being built so they're super lightweight, and that's kind of all you get when you read up on it. But what can you share with us in terms of like larger companies that you might have worked with that are dealing with like thousands of requests per second, really high bandwidth and throughput? What can you tell us about those challenges, and what does it look like in that world?
Yeah, that's a really good question because you're right. When you introduce a service mesh, you are adding latency to your system. You are adding resource consumption, so CPU and memory. And in fact, you're not just adding one proxy between every hop. You're adding two proxies. So service A talks through its proxy to go to service B's proxy to finally go to service B. So that is a lot of machinery in there. And, just like with any technology, right, that's the cost you're going to pay. And then you have to make the decision, is the value I'm getting out of the service mesh actually worth that cost? Now, in Linkerd land, we try and minimize that cost as much as possible. And I kind of alluded to that when we were talking about Rust for the data plane. Rust gives us a lot of very fine-grained control over memory allocation. It allows us to be very, very fast and to reduce, not just reduce latency, because with latency especially, it's not enough to reduce the common case. It's actually that tail case, what we call the P99 and P39s, the tail, the long tail of latencies. That's the hard part to reduce. So Rust gives us a lot of control over doing that. And one thing that we've done in Linkerd that's really different from other service meshes is a lot of service meshes are built on a very popular proxy project called Envoy. And Envoy is a great proxy, and it can do a lot of different stuff, but it is a general purpose proxy. And what we've done with Linkerd is we've developed these very focused, we call them micro proxies, and it's just called Linkerd 2-proxy, right? That's the micro proxy that Linkerd uses. And we've just stripped everything out. We've removed every kind of feature that you don't need, and we've tailored it just to the service mesh use case, again, in an effort to keep the memory consumption as small as possible, keep the latency profile as sharp as possible, keep the CPU overhead as minimal as possible. So getting back to your original question of, what have we seen in practice? I think in practice with larger customers or larger adopters, it kind of depends. It depends on the application. For a lot of them, the slow part of their application is not the additional 1 millisecond or whatever you're adding from the service mesh. It's the fact that their database is sitting there at like 250 milliseconds, and like that's the dominant kind of factor there. There are some organizations that have extremely latency sensitive use cases. They're doing like, trading, financial trading and stuff like that. So my sense is some of those companies just like don't even bother, right? Like, okay, we can't do anything that adds latency no matter what. Like we're going to bend over backwards to reduce every millisecond. So we're going to make, it doesn't matter how hard our lives are. The most important thing for us is reducing the latency. Some of them actually use Linkerd and they find that sometimes it can speed things up, which is weird. We have this very old blog post that we wrote. I think it's called something like Making Things Faster by Adding More Hops. Because of the way that Linkerd is doing load balancing decisions, we're taking into account things like, here's the latency of each individual endpoint. It's very, very intelligent the way it's doing load balancing. And because of that and because of the observability, they have claimed to us, and this is awesome, they've claimed to us that things are actually faster even though they have taken a hit from installing the service mesh. Their end-to-end latencies are actually faster. So it really depends on the application.
Yeah, that's really cool to hear. So what are the some of the biggest technical challenges other than like the network hops? Are there things like port exhaustion or any other sort of challenges that you've seen?
I think the hard challenges are probably more on the design side than on anything else. Certainly, I'm going to keep talking about the proxy because that's where a lot of the really complicated engineering goes. But the proxy, that Linkerd uses, which again is just called Linkerd 2-proxy. It's up on GitHub. You can find it, alongside all the other Linkerd repos there. Um, that thing is built on these very state-of-the-art Rust asynchronous programming libraries. So there's a library called Tokio, Tokio. There's one called Hyper. There's one called Tower. These are all kind of the underlying layers where the actual hard work, of being highly performant, modern day network software lives. And the proxy is, I wouldn't say a thin layer on top of that, but, as thin as we can make it on top of that. So a lot of the hard stuff happens there. And to tell you the truth, I don't even know how that thing works. It's like there's some great Rust programmers who are like doing stuff over there, and I just get to watch the benefits over there. So from my perspective, a lot of the challenges really are more on the design side. How do we make this thing fit into Kubernetes? How do we make it so it feels like the rest of Kubernetes? How do we make it so that no matter where your Kubernetes cluster is running, it will work? And how do we make it so that it is simple and lightweight while still being capable of doing all the many things we want it to do?
And the other cool thing that I've seen is this multi-cluster approach that you mentioned. So a lot of the times we deploy Kubernetes where maybe it goes to Amazon EKS or GKE or AKS, but some of these folks want to have their AKS or EKS talk to another EKS in another in another region. And I know Kubernetes Federation was a thing in the past. I'm not sure where that has gone, but what does the multi-cluster approach look like nowadays?
Yeah, so what we're seeing with kind of across Linkerd adopters, especially, is as people get a little more advanced with their Kubernetes adoption, uh, multi-cluster ends up being a very useful approach. There's a couple of reasons to do it. One is, kind of the normal reasons of, I want to have things dispersed geographically. So I want to have lots of different clusters in different geographical regions, either because I want to get closer to my customer or because, I want to have like failover and kind of disaster recovery scenarios. But the other thing that's driving it in the Kubernetes world is multi-tenancy. I think I mentioned I cut my teeth on Mesos. Mesos was very good at multi-tenancy. Kubernetes is not really that great at it. Things like CRDs are cluster wide, so you can really only effectively have one Linkerd per Kubernetes cluster. Namespaces are non-hierarchical. So there's all these reasons why if you're doing anything multi-tenant, it's actually easier just to give each tenant a cluster. So with all that driving it, kind of the thing that Linkerd can help with is cross-cluster communication. And not everyone needs that, right? Sometimes you have clusters that are just perfect replicas of each other and they communicate within themselves, and then they never need to, communicate across. But if you have a setup where you actually need services to speak across clusters, then our pitch to you from Linkerd is that we can make that happen for you in a way that is totally transparent to your application, and that gives you the same kind of guarantees that we give you around in-cluster communication. We'll MTLS it on both sides, so it'll be authenticated and confidential. It doesn't matter if it's happening over the open internet. If you've got an Azure cluster and you've got a AWS cluster and you're communicating across the open internet, that's fine. We'll use the same kind of TLS technology, and we'll solve the discovery problem for you. So you, as service A, if I want to talk to service B, you just make a connection to B, and Linkerd will figure it out. If B is local or if B is remote, it shouldn't matter to you. And then you can get very, very advanced, and you can start doing traffic shifting, and you could say, I only want a portion of traffic going to the local one and some portion. Anyways, it gets complicated, but we try and make it as simple as possible for you.
That sounds like my probably one of my next video ideas. I've got to get my hands dirty on multi-cluster.
It's pretty cool. It's pretty cool.
So I think we're coming up to your hour, so I don't want to keep you on too long. I got a question. Windows containers.
Yeah.
What is I know it's getting, Microsoft's getting a lot of traction on Windows containers. The adoption is getting there. So I think a lot of more of the legacy systems, enterprise companies will start to adopt Windows containers, or probably are already. What is Service Mesh doing in this space?
Yeah, so I'll tell you my understanding, and I'll put a big caveat here, which is that this is not an area of expertise for me, and so I'm kind of repeating what I've heard. But what I understand is that everything is basically ready for the service mesh to run on Windows-based Kubernetes clusters, except for the IP tables component. So the way that we deliver a lot of this kind of transparent behavior in Linkerd is when you boot up your container, we run this, or your pod, we run this init container, and that init container does a bunch of IP tables wiring so that all TCP connections to and from that pod go through the Linkerd proxy container first. And that's what allows us to add the proxy to, or the micro proxy to these pods without the application even being aware of it. But that IP tables thing is we don't have support for yet in Windows containers. That's my understanding. If I'm wrong, then please send Marcel an angry email and tell him how wrong I am. That's my understanding.
Oh,
His email address will be right here below.
Oh, that sounds good. I'm happy to take that one. I'll take one for the team. Yeah, I think Windows containers will be, I think a lot of folks will start moving towards that, and I'm sure Microsoft would add that support. And given I think the Linkerd stack can probably cross-compile, I'm sure you probably won't have any dramas there.
Yep, yep. And as far as I understand, they are working on it already.
So last question, what's next for Linkerd?
Oh, gosh. This was kind of the culmination, I wanted to be on this show, and then, now we can shut it down. I don't know if there's a next. Yeah. I think for us, there's a couple things. One is, we have a specific feature that I really want to deliver early next year around policy. So we want to give you the ability. Right now, Linkerd just says yes to every network request. You say, I'm A, I want to talk to B. The proxy does its best to make that happen. I want to give you, the operator, the ability to say, no, A is not allowed to talk to B unless it meets these conditions. So that's kind of on the feature roadmap. Beyond that, I think there's something that I would love to do, which is to give you the ability to run the proxy outside of Kubernetes. I think the control plane will have to always be in Kubernetes. We've made too many assumptions around that. But I'd like you to be able to expand. We call this mesh expansion. To expand beyond the cluster itself. It'll probably be a little harder to set up because we don't get all the niceties of Kubernetes. But there's no technical reason why you shouldn't be able to do that. And there's a lot of use case for that. And then more generally, I think the goal is, again, we want to make Linkerd boring. We want to make it this thing that you install. It just works. You don't think about it too much. And you, as the operator, are then freed up to do the things that you really want to do, which is build this platform, this amazing Kubernetes and Linkerd based platform that in a way that's reliable and secure and scalable and flexible and nimble and like all those things that you want. So that's really, in the end, that's really the goal for us.
That's cool. No, that's awesome to hear. I like the focus, the attention is more on the user and the operator rather than here's a bunch of CRDs, figure it out.
Good luck.
And open a GitHub issue over here if there's any,
Yeah.
So
And I've been very happy to have a community centered mostly around the Slack channels. If you visit us on Linkerd, what is it, slack.linkerd.io, there's a community of people who are really helpful, really friendly, and they're just eager to get you started.
Cool. So that was my next question. Like, if anyone watching wanted to get involved and they want to learn a bit of Rust and things, where would they go?
Yeah, start with linkerd.io is always a good starting place, and then hop into the Slack if you want to develop. There's a contributors channel there. There's a Linkerd2 channel. There's a jobs channel. We try and make it as fun as possible, and a lot of friendly people. So come in and say hi.
Awesome. Well, thanks, William, for coming on and giving us the opportunity to come on and talk about.
My pleasure.
This. It's really exciting, really awesome. This is the first thing that I've done like this on this channel, so it's going to be pretty cool and exciting.
Well, I hope I hope it's great then. I hope it does really well. Gosh, I'm the guinea pig.
And you probably have a lot of extra emails to output, so I won't keep you hanging much longer. But yeah, thanks for coming on.
Yeah, thank you for having me. I really enjoyed being here.